Negative emissions has been on the radar for a while. People have been proposing to do ocean-based fertilisation experiments and land-based, and we thought it was a time to get scientists and social scientists together, regulatory people together, policy people together, to talk about the issues, how we might actually reduce our carbon footprint and draw down carbon, but also how we might actually put it in a socially acceptable framework to do these sort of experiments or scaling experiments.
We are looking at a carbon sequestration demand by 2100 of about 120 billion tons of carbon. And that is, if you want to put it bluntly, a column of pure carbon of 13 by 13 meters from Earth to the moon in terms of scale. So it's a massive endeavor. And that is the sort of challenge that we are looking at. And that's what we will have to do to stay within that 1.5 degrees warming.
The only way we can do it in a reasonable fashion is actually using the natural ecosystem. Technology, I don't think, can do it on a scale that we currently burn our fossil fuels.
Yeah, so we have to take the carbon out of the atmosphere into biomass, which is like 100 years maybe at best, but we're trying to talk about 100 million year old coal that was locked away. So permanence is about taking a living biomass, which is both risky to loss, but also can continue to grow, and storing it in soils, really. So charcoal, biochar, taking that biomass, maybe the stems and the prunings and the branches, rather than chopping off the trees so they can continue to grow, and taking that part of the plant that would normally rot and go back up into the air and charring it and forcing it into the soil and locking it away. That's the permanency part. Enhanced rock weathering is another way of making it more permanent, that the roots and the agriculture system can accelerate natural rock weathering processes. So you take carbon dioxide and put it onto magnesium or calcium and increase that limestone formation, which has benefits for the soils. That's another permanent, the geological feedback system that can be accelerated.
We've also got afforestation, which is where we plant trees where they haven't grown before. So we often talk about reforestation, which is where we try to grow trees where they used to be but have been cleared, usually because of human development. But afforestation is taking over new land for the sake of growing trees. So this gives us, I suppose it's a net positive gain in terms of the amount of carbon that's sucked away, leading us to more negative emissions. We've also got blue carbon, which is where we look at ways that we can grow more plant life or seaweed in our marine, coastal and ocean areas.
The ultimate large pool is the oceans. I think land is where we actively practice and probably is the first place to start. But the whole continuum down along the hydrological cycle to the oceans will ultimately be part of the solution.
In the ocean, we remove about 90 gigatons of carbon per year, and it exhales about 90 gigatons of carbon a year. On land, we do about 120 gigatons, and respiration accounts for the same amount. So as scientists, we want to enhance that ecosystem or utilize that ecosystem to draw down our carbon. And I think this conference here will explore the various technologies to do that, and explore the social license to do it as well. Whether it's ethical to actually, say, enhance this ecosystem over this one, what are the social consequences of doing that?
And so with negative emissions, we can think about each of these different types of technological approaches and imagine how they might affect people and how this might lead to social acceptance or social rejection. So for example, if we're planting a whole lot of trees on land that used to be farmland, you can find that people who feel some sort of personal benefit, perhaps they like the view of what they see as being an agrarian landscape, if they feel that's being taken away from them, they might oppose that land use change. Or similarly, if we think about the more technological options, it could mean that we're developing quite substantial industrial developments, and this could alienate people that live next to where they're being built. But as well, we also get people who can object to technological or policy change from more of a moral perspective, so they might not necessarily have some direct impact on their lives, for example, living next door to where a development's happening, but they might have a moral objection to the change itself. And I think that that's the type of concern that we often see around ocean iron fertilization, where there's ideas about how people ought to treat the environment and how management ought to be interventionist or non-interventionist in different cases. And the way we talk about these issues and the way we talk about the risks and what we're actually doing will affect those attitudes just as much as the reality of the technological approach itself.
There have been negative emissions conferences in the Northern Hemisphere, recently one in Europe. Bringing this now to Australia hopefully will help to bring it as an important topic to the Australian policy makers and to the Australian public, where we need to start to inform people that this is a really important thing that we need to do. It's not a question whether we need to do it, we need to do it. And Australia actually can play a really big role in this internationally.